I want to talk about how to use Air Magnet Survey. The first thing you want to do is to open up a new project, and you have a choice here between the GPS and the non-GPS projects. And then the first thing you need to do is import a floor plan. So this can be an image, basically. Any image file is acceptable. And then you want to choose whether or not basically the type of space you have: office, open office, warehouse, and outdoor space, and that determines the radio frequency obstruction level, and the signal propagation assessment is automatically inputted, but you can change the signal propagation to anything you want. And when you press next, you can enter a description of your survey, and that will generate a new project. In this case, my map has markings where I'm going to put access points. This is an outdoor survey, and I'm choosing the passive survey. Passive means that we are looking for radio frequency interference before we've connected to an access point. So what are the existing interferences? And we just take our guy and we walk around the map, and every time we move we click, and that registers our data. So you would put this on a laptop. Microsoft Surface tablets are very good for making these surveys, and you just want to walk around, and every few feet just click. You can pause the survey and then click again to resume. If you make a mistake like I'm making, then you can press the undo button. Now note, I used an image from Google Maps to do the survey because this is an outdoor survey. We want coverage in the yard. When you save your survey, your passive survey data, then you can display it. I should mention you should wait a few seconds after each step to collect the data. What I'm going to show you here is the actual data we collected. You can see we can filter the data by SSID, and we can filter by channel on the left. If we drag this bar, we can set a minimum or maximum threshold for the signal. In this case, our signal ranges between -60 and -80 throughout the outside. The building itself has Wi-Fi. On this screen, we've done a passive survey for a indoor building, which also has a good Wi-Fi coverage in the office, and which is green at the bottom. And as we drag the slider up, you can see we have poor coverage up at the top. We have very little Wi-Fi coverage in the warehouse. So if we set our signal to 70, you can see in the gray areas we have no coverage at all, pretty much. Of course, we can zoom in to any area on the map. And the measure mode helps you calibrate the dimensions of the area, which will affect the results of the survey. So you're asked to input the measurements ahead of time, but if you didn't, you can always measure later. And the laser measure is good for this. So measure 2 points on the map, and then select them with the push pin. And in this case, we measured 94 feet. and then we enter the actual dimension. 94 feet is what the software thinks it is, and let's say it was 150 feet, so we put 150. It automatically recalibrates in the X and Y direction. So the software also lets you plan the location of some access points for a so you can choose where your access points are going to go, and you can enter different wall types. So you can draw a brick wall or a drywall, and that lets the software understand signal propagation. It can predict how far the signal will travel given the wall. You can also highlight areas based on the type of area that you have. So a cubicle, an office space, a warehouse. So in this case, I'm highlighting cubicles, and the software understands that they are going to block the signal a bit. And this, I'm highlighting a warehouse. You can't overlap regions. The software will get confused. But so if we highlight this area and say it's our warehouse, and then we highlight the next area and say it's an elevator shaft. Well, I made a mistake here. I'll do it again. And you don't have to draw a square. You can draw any shape you want, basically. So that's our elevator shaft, and this is our warehouse. And then what we're going to do, we're going to add, we can add areas where we want coverage, or the software will assume. So we've highlighted this area. This is the area where we want Wi-Fi coverage, and then we can add exclusion areas. So these are areas where we're not allowed to install access points, let's say. And then the advisor, we set our parameters. So what is our minimum signal strength? What kind of APs are we using? Their height, the antenna gain. In this case, we're doing 2.4 and 5 gigahertz, and we want to have a minimum of minus 75. Your parameters might be different, and then we can choose which channels we plan to broadcast on. On high density applications, you need more channels, and then the software will automatically figure out which areas get which access points based on the coverage, and it does some number crunching. This takes a few minutes, could take a while depending on the size of your building. And then we have a heat map. So it's figured out based on the walls and the areas that this is where we should put our access points. In this case, it's selected 5 access points. And you can see we get a higher signal closer to the access point. The other thing we can look at is we can filter our survey results by channel. We can also filter our survey results by SSID. If we don't like what the software did, we can place access points by ourselves. And one of the things we can do that's really cool is that we can change the antenna parameters for a given access point. We can even include MAC address and IP address. But the antenna patterns, the software comes preloaded with hundreds of antenna patterns for many of the most common APs and AP manufacturers. So we can search for a pattern by vendor and then choose an access point. So you can see we have antennas that are dipole and Yagi, different kinds of antenna types. And if you don't find the antenna type you're looking for, you can draw your own antenna. So you can draw the antenna by pressing New and then moving the circles to the middle to make the shape that you want. Of course, you're not going to find an antenna with a pattern like this, and you can program the azimuth plane and the elevation plane. The other thing you can do is you can display heat maps just by signal strength, noise level, and SNR. There are many different parameters that the software collects. Noise level is important. Actually, what's most important is the signal strength and the signal to noise ratio, and but you can filter by a specific access point if you want as well. So this shows a signal strength of just one access point in the entire area versus signal strength of the entire facility. The PHY data shows a predicted data transfer rate, which is important in some applications. And then yeah, so you can also filter heat maps by access points by using the bar on the left and selecting a given access point. The software in the passive survey automatically detects each access point and its channel. And then you can place your access points on the map that is detected. So the software detected access points, but it doesn't necessarily detect their exact location. And then you can specify their exact locations, and that allows you to run a simulation. Now here I've put a push pin. I can put a push pin at any spot, and then it will give me more details about the measurement, including the access point, signal, and the SNR, and the data transfer rate.